Switching gears a little bit from force, mass, Newton's laws, we're going to talk about a lab that I like to do for waves. This is a spectroscope. Students are going to make their own spectroscope. This one is a lot of fun. It reinforces, you can pull these back out when you get to the astronomy unit, but it's very helpful for bringing home astronomical tools as well, but especially wave behaviors and diffraction, but also refraction. So let us get started. What your students are going to do, and I'm going to give you several options for this because it is a really flexible lab. You can either bring paper towel tubes, your students can, or you can. You can find a poster tube. I grabbed this at home just to see how it compared to what I do in the classroom. But one of the best, easiest, most effective things is to get cardstock paper, and obviously you want to pick a color, black in this case, that will reduce any kind of light being transmitted through that material. So black is going to be the best. I've got a piece that I cut out for this lab, but take a piece of cardstock and have your students roll it into about a 3 centimeter diameter tube. This part's really easy, but you're going to have them make a tube of their own. And you're going to do that long ways. Sorry, I showed you wrong. You're going to do it lengthwise, okay? Or hot dog style, whatever your kids say. And you're going to roll it and then just tape all the way down. Again, you want to make sure that your seams are not compromised in any way as far as light goes. So roll that out, make their tube, or you may already have a tube. So here's what I do. I have just modified this to make it a little more student friendly, and it is just as effective, I have found. So in this case, let me go back a little bit. I've also provided you with the cutting guide. It's gonna help you and help students to cut about a 30-degree angle slit at the end of the tube. So at the end of the tube, you are going to cut a slit down at about a 30-degree angle. Let me take this out. We wrap that template around the end, and you can just cut right through the template, okay? And that gives you that correct angle. What your students are going to do is you can even let them choose. They can bring an old CD, and they'll slide that all the way down into that slit, or you can use the diffraction paper that we have provided. Now this really is the gem. This, I believe, has so many more applications, and even in this lab is more effective than a CD. So I really recommend you use the diffraction grating. That is this really thin, transparent paper. You're only going to need a small square. I think I've given you the measurements in this lesson plan as well. And you can just cut out a square that is much smaller than the diameter of this CD, something that'll fit right in this slot. Or you can actually put the diffraction grating on the very end of your tube. This is what my students and I did. Don't cover it, open that end up, and just put a square of diffraction grating on the end of the tube. Many ways to do this. With the exception of this is the important part. On the other end of your tube, your students will take the cardstock, the black cardstock, and just like I did here, they're going to cut out a square that is big enough to cover the end of the tube, okay? And then you can have them make it a circle, and then I just took electrical tape, I think that's in your supply list, and just electrical tape all the way down the sides, okay? Now, I did this part for my students just to make sure it was done correctly, but you're gonna do about a 5 centimeter slit that is about 1 millimeter wide right down the end. This is where light is gonna pass through. I know you guys all know that, but this is the end light's gonna come through. All right, now, depending on which model you picked, you are going to either cut out a square that students will look through, almost like a periscope. You're either going to cut that, or if you choose to just put the diffraction grating on the end, that second model I kind of told you about, they're going to actually just view through that diffraction paper. I just really reinforce with my students not to get their eyes on that paper or touch it. The oils start to cloud it and it's not quite as effective. So if they can grab it from the ends, that's better. Okay, so once you do that, the whole idea is that you have blocked out light, and you are going to point your slit up toward the light. So you can even point it toward the sun if they're using this model and they're not directly looking at the sun, or somewhere near it, a white t-shirt of a classmate, anything that is reflecting light or directly emitting light, you're going to point the slit up. And the students are going to look in the tube through the diffraction grating or the side, kind of that periscope side, and what they're going to see is that light being split or spread on the paper or the CD. And they can kind of get an idea for what gases are coming off of that object as well by the colors that they're seeing bounce off of the walls of the tube and the material itself. It is really cool. So they're seeing light split, and it gives them an idea of how the spectroscope works, and it also gives them an idea for later on how we kind of decide the composition of different stars and planets or whatever, objects in space. And it also again reinforces the fact that light travels in waves, and it travels, we see it as white, but its component parts are actually the Roy G. Biv, as you know. Great lab for your students and fun. Thanks.